Hi, I'm Gina, and today I'm going to be walking you through how to build your first AIP Logic function. AIP Logic is a no-code tool that allows you to build and publish functions that use large language models and semantic search in combination with your ontology. Before we get started, a quick word for our founder.
Discover how Palantir customers unlock more value from Foundry and AIP thanks to our live instructor-led trainings. We are Ontologize, a group of former Palantir engineers who love teaching. We've trained thousands of Palantir users at leading organizations around the world. Unlock the full potential of your Palantir deployment by going to ontologize.com.
Starting from Foundry, we're going to be looking at the ride object type today. So let's take a note of the properties that the ride object type has. So we have the name, the park section where it is a description of the ride, the type. Notably, we have this embedding property, which is an embedding computed from a concatenation of the description and the name. So that will come in handy later. But first, let's go into Logic and start building. So from wherever you are in Foundry, you're going to hit Control-J, and you're going to search for Logic. So here we have AIP Logic. And so you're going to click on it. So here we are. We're going to hit Create New Logic Function. And let's call this Theme Park Guest Greeter. Hit Browse, save it in your project. And then hit Save. So here we are in our empty AIP Logic function. Our goal here is to build a function that greets the guests that are coming to our theme park. Eventually, we're going to want to provide them with a full suggested itinerary. But we're going to start simple and just build a function to generate a nice greeting for each guest. So because this is a function, it takes an input and it produces an output. And of course, there are some things that are going to happen between those steps. So we're going to start simple and just build something that greets our guests. In order to greet the guests properly, we probably want to know their name. So from here, let's add our first function input, which is going to be the guest name. So from here, you're going to hit Add Function Inputs. And we're going to call this guest name. It's a string, it's required, so we can set this to be required or optional as a function input. And the first block that we're going to use, the building blocks of AIP Logic are called blocks, is going to be the Use LLM block. So we're going to click Use LLM or Large Language Model. Click on that. So here is the Use LLM block. So here you can find some guidelines on prompts and how to structure your prompts. Here we have the system prompt and we have the task prompt. We also have tools here, which we're going to get to in a bit. Here we can also specify the output type, which model we're using. So we have GPT and a couple of other big ones. We can set a temperature, set the seed, and max tokens. So here, we're just going to keep everything with the defaults. So let's focus on the system prompt and the task prompt. So in the system prompt, you're describing what is the task you want the LLM to perform. Now in the input data, that's where you put the data that it's going to be working with, perhaps from variable inputs or other variables that are generated over the course of your function. And we will see an example of that. So here, what we want this LLM to do is greet our guest by name. So in the system prompt, let's describe the job here. You are a friendly greeter at the theme park. Greet the guest by name. And so the input data is, of course, going to be the guest name. And so here, we're going to say guest name. And to reference a variable, we're going to type a /. And here you'll see that we have just one variable right now. It's the guest name. So we're going to click on that. And now let's give it a try here. So here is where we preview the run. So for the guest name, I'll make it mine. So Gina. And then I'll preview the run. Now here we can see the result of this function. So welcome to the theme park, Gina. We hope you have a fantastic day filled with fun and adventure. Now on the side here, this has opened up the debugger. And so in the debugger, you can see the steps that the function is going through as it executes. So here in the use LLM block, you can see everything that's going on under the hood. So here we can actually see the raw prompt that is generated from these inputs. And so here, if I hit show raw, then I can see the actual prompt that is getting generated. Now, there's nothing terribly interesting going on here yet, but we'll return here as we go along and we'll see some interesting things happen. So let's close this. Let's add another level here by giving our LLM a persona. So maybe we want to be greeted like Yoda, for example, or like a pirate. So here, I'm actually going to add another input. So I'm going to hit add, and I'm going to call this one persona. How do we want the guest to be greeted? And so here, we're going to adapt this prompt. So instead of greet the guest by name, we're going to add something here. So we're going to say greet the guest by name in the specified persona. So here, we're going to say the guest name, still guest name, and the persona, this is going to be a variable. So again, we reference variable, we type a / and hit persona. Note that in the preview run section here, we have the persona field now. I'm going to say greet me like a dog. So I'm going to say preview run. And here we can see the debugger pop up again. And so here we have our dog-like greeting, gave me a couple of paw prints too. Now our greeter can greet the guest by name. It has a persona. So let's take this up one more level and have it start to create an itinerary for the guest. Well, an itinerary is not going to be terribly interesting without knowing the user's preferences. So why don't we add one more input here called preferences, so we can generate an itinerary that actually makes sense for this specific guest. So here we're going to call this preferences. And so now let's adopt the prompt. So you are a friendly greeter at a theme park. Generate an itinerary for the guest based on their preferences. And so now in the input data, we're going to say preferences / and we have preferences. So now we have Gina, greet me like a dog. What are my preferences? I like slow rides. Preview run. We have a problem. You saw in our ontology that we do indeed have a data asset of rides, but none of these rides are in our rides. So these are made up. Let's take this up another level and try to make these responses more grounded in reality by querying our data. So what we're going to do now is we're going to add our first tool. So in the use LLM block, you can add tools to give your LLM extra capabilities. So some of the capabilities you can give it are applying actions. You can give it a calculator if there's any math that needs to happen. You can have it call another function, so maybe an AIP Logic function or a TypeScript function. You can give it access to the current dates, or you can have it query objects. And that's what we're going to do. So here, I'm going to add the query objects tool. I'm going to add object. Which object do I want it to query? I want it to query rides. So here we have our ride object. And you can see here that I've given it access to all the properties and none of the links because we don't need this. And now, of course, let's make sure to include in the system prompt that we want them to look at the rides. Only use results from rides queried. I'll try this again. I like slow rides. Let's change the prompt to, I want a ride with water. Preview run. So what can be interesting is that if you go over to the debugger and look at the generated prompt and hit show raw, you can see everything that is going into this prompt that is generated by the combination of all of the things in the use LLM block. So that can be something that's interesting to read through. We're not going to focus too much on it right now. What we are going to focus on is the LLM tool use. So here we can see its chain of thought. So we can see it saying, first, I will query the ride object type to find rides that have a description containing the word water. So here it's describing the steps it's going to take. And so you can see that it queried objects, and it's looking for the ones that say water in the description, takes those objects, and it uses that to generate its response. So now, what's great here is that we have an itinerary that is grounded in our reality. Now, let's see exactly how far we can take this. So in the preferences, let's say maybe I get dizzy easily. So I want to say, I want a ride that won't make me dizzy. So I'm going to hit preview run. And so here we can see what the LLM is doing. And this looks like it's having a little bit of trouble. So here it's failing. It's going to fail again. Okay, so eventually it succeeded. But let's take a look at what it did. So it failed actually many times. So what it's doing here is, because I asked for rides that won't make me dizzy, it's trying to filter the rides where g-force is less than 2 and the x, y, and z accelerations are also less than 2. So it's basically trying to write this query against the object set. Now, what I know is that this is not going to work. And the reason it's not going to work is because these are all time-dependent properties. So you cannot simply filter on them like this. So that's why it keeps on failing and failing and failing again. Now it tries something else. So it tries to do filtering on the descriptions. So it tries to filter on the descriptions that indicate a more gentle experience. Tries something similar, fails, and we can see it's returning 0 rides from these queries. Tries again, returns 0 rides. So then what it does in this step is it just grabs a set of 10 rides and then manually tries to identify the ones that will cause dizziness. And so finally, it does return an output, but again, this failed a lot of times. So let's try another one. We'll say, I want rides with crazy acceleration. Try to preview the run. Let's see what happens here. All right, so here we can see it's trying the same thing and it failed. And so let's take a look at this failure. So if I hit show more, it's going to say invalid argument, property not sortable. So the reason it failed is because it tried to filter once again on time-dependent properties, which doesn't work like that. So we're going to need to try a different approach because clearly this has its limits. It performs perfectly well with certain preferences and fails with others. So the way that we're going to deal with this is by using semantic search. So again, thus far, it's essentially been writing a SQL query against the ontology, which is great, but can have limited success with certain types of queries. So what we're going to do here is we're going to add a semantic search block, feed the results of that into the useLLM block, and then allow the useLLM block to use the results of the semantic search to construct its answer. So what you might have noticed with some of our previous queries, for example, when I said, I want a ride that involves water, is that we are doing some sort of rough keyword matching. Now, semantic search goes well above and beyond that. So semantic search allows us to find the most relevant results based on their meaning. And that is going to help us get much more relevant results. So let's add in our semantic search block. So from here, you're going to hit add a block. And now before we were using the useLLM block, but this time we're going to hit semantic search. And we're going to call this one find relevant rides. So in order to conduct our semantic search, we have to have a corpus of text to search. And that corpus of text is going to come in the form of an object set that has an embedding property. So here, we're going to have to select an object set that has an embedding property. So we're going to hit select variable. And now we're going to hit create new object set. So we're going to search rides. And here we have a ride object type. So we're going to click on that one. Now, when I did that, it made me a create object set block. And so here we're just invoking the set of all rides. And so here we still have our semantic search block. And so we're starting with all rides. Now next, we have to identify what property on rides we are searching. Now, if I'm going to select object property, and you'll notice here, I only have one option. So my only option here is the embedding property. So if you haven't seen an embedding before, an embedding is a vector representation of a string that captures its meaning. And these embeddings are generated by models such as OpenAI's Ada. So in this semantic search block, it's going to return some number of relevant objects. So in this case, it's going to be some number of relevant rides. And so here, let's say that we want to have 5 rides returned. So we're going to hit manually enter value, and change this to a 5. So last but not least, we have the query. Our goal, again here, is to identify the rides that have a description that is closest to the query in high dimensional space. Now, the query is going to be the preferences, of course. So for the query, we're going to hit this dropdown. And we're going to hit preferences. So what it's going to do here is identify the 5 rides where the embeddings of those rides descriptions are closest in high dimensional space to the preferences. So now we have the semantic search set up, but we're not using it. So what we're going to do is we're going to take the results of the semantic search and we're going to feed this into the use LLM block so that the LLM can compose its response using the results from the semantic search. And so let's adapt the system prompt a little bit first. So we're going to say, generate an itinerary for the guest based on their preferences. Only use the rides returned from the semantic search results. And so let's get rid of this tool. We don't need it anymore. So we're just going to scrap that. And then in the input data, we're going to say semantic search results. And then we're going to hit a /. And so here, you might remember find relevant rides. That is the name of our semantic search block. Now, you might recognize this icon. This is the icon for the rides object type. The return type of the semantic search is an object set. And so here, we're going to click Find Relevant Rides. And we have to pick a property or a couple of properties, but we're not just going to give it the entire object set that we found. So here, let's give it the name and the description. So we're going to add 2 properties. And then here, you'll see that it actually created another block for us. So the block that it just created for us takes an object set and prints it as a string. So you can see here, it takes the object set find relevant rides. And for every object that is returned, it prints it in the following format: name, description. And here we can also cap the number of objects, but this will just be 5 because we're only returning 5 objects from our semantic search. So I also wanted to point out here that in the input data, you'll see that under semantic search results, it's referencing the variable find relevant rides formatted, which again takes the find relevant rides object set and prints it as a string. So now let's try this out. So for the preferences, I'm still going to say I want rides with crazy acceleration, and let's see how it handles that prompt. So I'm going to preview the run. And here you'll see that it doesn't have any failures at all. And let's look at the response. So it's recommending the Alpha Centauri Expedition, Astro Air Race, Solar Surfer, Warp Drive. Now, as a human, I can look at these descriptions and see, yes, the meaning is similar to the query, I want rides with crazy acceleration. Even though none of these rides ever explicitly mention acceleration, they all have descriptions that are fairly semantically similar to high acceleration, and that's how they end up there. So let's summarize what we've done so far. So here we have 3 variable inputs. So we have the guest name, the persona that we want to be spoken to in, the preferences. Now we have this block, which basically pulls in all of the available rides in our theme park. We have the semantic search block where we find the relevant rides based on the user preferences. We take that return object set and we print it as a string. And then we feed all of that into the use LLM block. And here we're really using the use LLM block to synthesize these results and return it as a nice coherent message spoken in whatever persona we want. And so our last step here is going to be to save our function and publish it. And then after that, I'm going to quickly show you how to use this in Workshop. So from here, you're going to hit save and publish. Note here that every logic function has to have a unique API name. So if your colleague, for example, has named their function the same thing, you might want to add your name to the end of it just so you don't have any errors. And now we're going to hit publish. And so from here, we can go ahead and use our function in Workshop. Now, before we go ahead and put this into our Workshop, I want to take note that in this case, our function is returning a string, but it could return other data types such as a number, or it could even produce edits to the ontology. But again, in this case, it's just producing a string. So let's take a look at how to display that in Workshop. So I'm going to hit Open Workshop. And now from here, I'm going to hit New Module. And I'm going to call this Demonstrate Guest Greeter. And then I'm going to hit Save. And here, I'm just going to get rid of this section. We're just demonstrating how this works. So from here, I'm going to hit Add Widget. And I'm going to search for Logic. And you'll see that I have a couple of widgets in Workshop just for AIP Logic functions. We have this widget, which shows the logic chain of thought as it's running. And we also have this widget, which just shows AIP-generated content. I'm going to use this one for now. So you're going to click on AIP-generated content. And so here, we're going to select a logic function. And I have theme park guest greeter. And now I'm going to need inputs for these variables. So right above this section, I'm going to hit above and put a section above. I'm also going to stretch this one out. And so I'm going to hit Add Widget. This is going to be text input. So I'm going to have one of those, and I'm going to call this one guest name. And I'm going to name the value it produces guest name. And then I'm going to add another section below, add another text input. And this one is going to be persona. And its variable is going to be called persona. And then I'm going to add another section below. Once again, a text input. And then this is going to be called preferences. And the string value is called preferences. And now we're going to go back over to this widget and feed those variables in as inputs to the function. So for the guest name, and for the persona, and for the preferences. Now let's try it out. So guest name, Gina. For the persona, I'm going to try a cat. And then for the preferences, let's say I want slow, gentle rides. Now I'm going to hit Run LLM. It's going to think. And so here we can see the ride suggestions, and I can verify that these are all indeed real rides in our theme park. So there are also many other ways you can use your AIP logic functions, but this is just one way to use an AIP logic function that produces a string output. There are a lot of other things you can do in AIP logic, but this concludes our intro. Thanks for watching. We hope you found this helpful. Be sure to let us know what you want to see next in the comments.